Sometimes if you are interested for finding the numerator and denominator, so this is numden. So the numden function extracts the numerator and denominator from an expression. So if you have some expression, and if you want to know that what is the numerator and what is the denominator, like this is the expression you have, and what is the numerator here? This is the numerator, okay, and then this is the denominator. Y is equal to this and this. So num den, these are the variables. Instead of writing num and den, you can write x, y also. There is no problem. So num den, this is the function actually, and y is the expression. So numerator it finds 2 times x plus 3 square, and denominator x square plus 6x plus 9. So if you have x plus 3 divided by 3x minus 10. So if you say numerator and denominator, this is the numerator and this is the denominator, you will find. If you want to multiply, see, this is also one thing. So you have found the numerator. So numerator is this and denominator is this. So just like you have the two expression, you want to multiply the two expression. So how you can multiply? So here num and den, this is the variable name, this is the expression, numerator. This expression takes the numerator, this expression takes the denominator, and you are going to multiply. Once you multiply, you are getting the answer. 2 times means this multiply by this. So this is the multiplication, and then you can simplify using the simplify function. You can simplify numerator plus denominator, you are adding. So once you are adding, you are getting like this. So here question is that you can multiply the two expression, you can add the two expression, and you can divide the two expression. This is also one command here, which is the expand. Expand the numerator. Expand this. So numerator is this. Once you use the expand function, means it is making the expansion. So x plus 3 square. So you will have the x square plus y, a square plus b square, a plus b whole square, a square plus b square plus 2ab. So you have a square plus b square plus 2ab. Generally we do like this. Now if you have the w, then same, with the help of the same also we can create the expression. So within the single quote, whatever you have written from here to here, this is the expression, and this is the expression assigned to the w. So w is the symbolic expression, right? And if you go for the expand w, then you are getting the answer like this. So here within the expression you have the equal to sign also, okay, so there is no issue. So you are getting the expression like this if you go for the expansion. If you just multiply these two, so x to the power 3 minus 1, x raised to the power 3 minus 1, this is the left side, and right side you can see x minus 3, x plus 3. If you can multiply, then you are getting this thing. So do you know how to multiply? And you will get answer this. You can use the formula also, I think. A square minus b square, a plus b, a minus b. So a square and b is a square minus b square. A square is what? X, b square is what? 3. So a square minus b square, x square minus 9. So this is the function for the solve. If you want to solve the equation, then you can do like this. So the input to solve can be either symbolic expression or string. So you should have the symbolic expression or just like the string. This is the string. Okay, this is the string. So either you can separately define y is equal to this, or you can within the same function you can define the string. So the y is assigned to this string means y is the symbolic expression. So the input to solve can be either symbolic expression or string. If equation is a symbolic expression like this, or a string that does not contain an equal sign. So here you have this. Or a string that does not contain an equal sign. So here you should not have the equal to sign, just like we have seen in the previous. Then solve equation, solve the equation. Equation is equal to 0. How it is going to solve? It puts the equation, whatever is here, it gives assigns to 0 and it is going to solve. So here you have the x square plus 12x plus 10. So here x square plus 12x plus 10. And this will become equal. It is going to solve like this. So once you are solving the expression y and y is equal to this, so this is y is equal to this equation y is equal to 0. So this is what quadratic equation. And you can use the formula for solving the quadratic equation. So if you use the formula, you will get the answer like this. Let us say, so you have the same xy already behave. X we have already declared the symbolic, and okay, y is also symbolic. So you can say like this. So y is equal to this. Now what you want? You want to solve for y. So what answer you are getting? Minus 26 raised to power 1 by 2 minus 6 like this, and plus side. So this is the answer you are getting. So here, if you have defined the expression y using the sim, which is the expression, then you can get like this. Otherwise, you can also do like this. If this is the, since x is the symbolic variable, so if you are using the x, then it is also automatically, this is the, just simplify this. Since x you have already defined as the symbolic, and this is the expression. This expression is, it means this is the symbolic expression. So if this is the symbolic expression, you don't require to put the single quote. So that's why if you solve this, if you can do this, then you will also get the same answer. So solve can take either symbolic expression or you have the string. So if you have x is not defined as the symbolic, then you have to give in the form of this. Then you have to use like this. Otherwise, since we have already x is the variable which is the symbolic, so you can directly use like this. Another way you can do, so you can say y is equal to, so since x is already symbolic variable, if you are using this expression and you are assigning to the y is the symbolic variable, and then you can use solve for y, and you are also getting the answer. And that's why it says that either a symbolic expression or you have the string. Important this thing is what? We are using the MATLAB for solving the equation. So sometimes if you are interested to find the value for the quadratic equation, so with the help of the MATLAB you can find the equation. This is important to learn. Use MATLAB symbolic capability to solve an equation. If you have k is equal to k0, this means k0 like this. K0 exponent minus q divided by RT. So we are going to solve for the q. So if you go for the solutions, then you will have expression k0 multiplied by e raised to power, this is what? E raised to the power minus q divided by RT. And you have the what? K0. So this is the same. If you go for the solution, then you are solving for the, you want to solve for the q. You need to find out what is the value of q. So you can do like this. So this is the by hand you are solving. And how MATLAB can solve this? Just see. What you need to do? First you need to define the symbolic expression. This is the symbolic expression. So x is equal to sim, with the help of the sim, k0 x. Here once you are going to use the function sim sym, you don't require to declare k q rt as the symbolic variable. in advance. You don't require. So because same, you are going to using the same, and this is the symbolic variable. X is become the symbolic variable, and in this symbolic variable you are going to assign this expression actually. So this is the usefulness of sim command. So once you go for the sim command, then you don't require to declare k, q or t as the symbolic variable. Now x is equal to sim, then you have written in the form of the string, you can say like this. So x becomes like this. Now what you are going to solve, this is the function, built-in function in the MATLAB for the symbolic computation, solve. So expression is x, you are solving the expression x for q, and once you are solving the expression x for q, you are getting the answer like this. And you can see that this is the RT log k by 0, because this is the, actually this is the, if you go for this, then you will have the minus RT multiplied by k0 divided by k. So this is same you are getting.